Hi everyone, welcome to Global AI. Back together. We're very glad to see you all again. My name is Sami. I'm a Microsoft AI MVP located in Belgium. Hi everyone, welcome to Global AI Back Together. We're very glad to see you all again. My name is Sami, I'm a Microsoft AI MVP located in Belgium.
And my name is Sjoukje, I'm an RD and an Azure MVP from the Netherlands. The last couple of months, we as a global AI community have worked hard to put this event together, creating content and updating our website. We are very happy to be back together again, in person and virtually, to upgrade your skill sets, socialize and have a good time. And most important, learning together about AI.
After the last 1.5 years, we've noticed that the world is finally start opening up again, bit by bit. This also means that some parts of the world have the privilege to organize in-person events. And we know that many of you have missed the social contact with like-minded people. Unfortunately, not everyone is able to join in-person events yet, and some of you rather prefer to attend all events virtually.
We are sure that all organizers have prepared some amazing content for you tonight. You can now check into the event by going to globalai.community/check-in. Once you have done that, we will send you some awesome Global AI community swag. There you can also request Azure passes for the workshops. And if you share from where you are attending this event on social media, including the hashtag Global AI Community, you will have the chance of winning some more swag in an even bigger swag box. We now have a quick message from our friends at Microsoft.
Hello everyone and welcome back. Welcome to the Global AI Community Conference, where we're here to help empower and connect AI communities all around the world. I'm so excited to be here today to witness all the amazing things you're going to learn all around the world, all about machine learning and artificial intelligence. My name's Jen Looper. I'm a Cloud Advocate Lead on the Next Generation Experiences team at Microsoft. My job is to help students and educators learn all about different technologies, and our specialty on my part of the team is all about machine learning and artificial intelligence. So I want to just take a few moments to welcome you again to the conference and to let you know about some amazing new curricula that we just released special for you, all about machine learning and data science. Let's take a look. If you make your way over to aka.ms/ml-beginners, you'll find your way to an amazing curriculum, completely free, open source, MIT licensed, all about machine learning. And this is classic machine learning. These are topics such as regression and classification and all sorts of clustering algorithms that you need to know to get started in machine learning. It's all using the scikit-learn library, and our curriculum always has a lot of little details that will get you excited about the topic. Let's take a look at, for example, the history of machine learning lesson. In our curricula, which again is all open sourced on GitHub and free to use, you can take a look at a sketch note about machine learning and get an idea about its history. We also start with a pre-lecture quiz that looks like this, and you can just take a low-stakes quiz to kind of warm up your brain and get ready to learn about machine learning. So this lesson has a lot of details about the history of machine learning, and it has little call-outs all the way through to help you kind of think a little bit more deeply about the topic in question. And it walks you through a really interesting experience all about the history, talks about Shaky and Eliza and the AI winter and then the AI chill, and then the explosion of machine learning and algorithms nowadays that has created this new kind of renaissance of AI and machine learning. We end all of our lessons with a challenge, with a post-lecture quiz, and a review and self-study where you might find an interesting video. This one features Amy, who's actually helped write the lesson. And then it ends with an assignment. And if you're using this in a classroom, you can go ahead and use the assignment to deepen your learning. So this machine learning curriculum has 12 weeks, a 12 weeks workflow, 25 lessons, 50 quizzes, and is all about a cool way to approach machine learning, which is actually via regional data sets. So what we've offered is around the world with classic machine learning. So you learn the basic concepts, some techniques, get your machine all set up for machine learning with scikit-learn, and then it jumps right into regression. But it takes a regional topic and explores it in like a series of about 4 lessons. We've had community contributions all around this content, including really interesting contributions for R as well as Python. You'll explore North American pumpkin prices. You'll build a web app using a dataset all about UFOs. You'll learn about classification using a dataset about Indian and Asian cuisines. You'll explore Nigerian musical tastes and learn about clustering at the same time. Then we tackle NLP, natural language processing, an absolutely exploding field with a lot of amazing lessons all about NLP, using datasets around hotel reviews in Europe. Then we travel to India, where you take a look at time series forecasting. Then we go to Russia for reinforcement learning, and we're joined by Dmitry, and we learn about Peter and the wolf and how we can train an environment so that Peter can avoid the wolf using reinforcement learning. And we end up with a little postscript lesson all about machine learning in the wild. So how is machine learning used nowadays? And you'll discover all about the ways different companies use machine learning in real life, in the wild. I hope you enjoyed this free curriculum, but wait, there's more. We also just released a new curriculum all about data science for beginners. So maybe before tackling that machine learning curriculum, you want to tackle data science. So here we have another amazing set of lessons. Here we have 20 lessons that cover 10 weeks of learning, all for free, all on GitHub. So you can take a look at, we have topics all around data science ethics. What is data? How to define data? There's a fabulous introduction to statistics and probability. You can work with relational data, non-relational data, get used to working with Python for data science, prepare your data, and then tackle data visualization to create really amazing experiences for your users as you explore and discover the quirks of the data that you're using. There's a lesson about an introduction to the data science life cycle and how you analyze and communicate your findings. And we finish up with a few lessons on data science in the cloud. So we take a look at how you might use data science in Azure. So for this conference, I think you might be particularly interested in these lessons. And once again, we finish up with data science in the wild. So real world applications of data science. So I want to just share these 2 curricula, which will allow you to have many weeks of learning, all about machine learning, classic machine learning, and data science. Coming soon, we're going to be offering a full curriculum on artificial intelligence, on AI. So stay tuned for that, and we'll be releasing that pretty soon on GitHub as well. Always free and always ready for anyone who's interested in learning topics and deepening their understanding of these amazing subjects. I hope you have a fantastic conference, and I wish you all the best in your learning journey. Thanks, and see you soon.
Now, we hope that you will enjoy this event today, and please remember to check in using the URL on the screen, and of course share how and where you are participating from on social media. In case this short evening event was not enough for you, please stay tuned for the Global AI Bootcamp in January 2022.
Hey, my name's Akansha Malik and I'm from Melbourne.
Exit Sami in Belgium.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Hey, Lever Tess. I come from Spain.
I'm Prasad from California.
大家好，我是卢建辉。
Nederland. I'm Alpha Casimo from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from USA.
I'm Joseph Isaac from California.
Hi, Medin Ali Daoud, Ghana.
Hi, I'm Anamana.
Merhaba, ben Türkiye'den Daron Gönder.
Hi there. Hi. 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 Hi.
Hi. Hi.
Can you hear me? Okay. Between the humans and machines. Thank you, Matthew and Mikhail, for inviting me to this Global AI Bootcamp 2021 in Bulgaria. Even I'm now online. I was recently in Sofia, and it was very, very good experience.
How can I help you? Hi, I'm calling to book a haircut for a client. I'm looking for something on May 3rd. Sure, give me one second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service you would like, what service is she looking for? Just a woman's haircut for now. Okay, we have it 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa.
Okay.
Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
Okay, what you have actually experienced now is a talk between a hairdresser and on the other side, a customer that wants to make appointment to this beauty salon. But the thing is that on the left side, hairdresser or beauty salon actually represents AI. So you saw that this conversation was not typical AVR conversation between man and machine. So the conversation was natural. Conversation was like some chat, and actually this AI that was representing the beauty salon used the accent that the woman who was calling the beauty salon was using to make it more natural, to make it local. And this is something that today is available, and this was demonstrated on the Google conference, how actually what can be achieved using AI today. Today's agenda is in front of us. So I will talk a little bit about the brief history of artificial intelligence. I will talk about deep learning revolution or multi-layer neural networks. I will also talk about what we can do today with AI and tomorrow, some examples. I will actually do the show me the money show, how actually AI will impact on jobs. What are new robotics doing with AI? And of course, very important ethical considerations that everybody are today talking about. This is me. I'm Tomislav Bronzin, Microsoft Regional Director, Most Valuable Professional. I have a huge experience in ICT and also doing projects worldwide. About the history of AI. So, not so long ago, to 1950s, there was one man called Turing who actually imagined something that we are calling Turing test, that is a method for determining the intelligence of a machine. There was different steps in getting to today with the AI. You can see that we have so-called AI winter, which was after the boom of early research. There was a pause. The pause was mainly because there was a huge enthusiasm about AI, but because of the lack of the computing power, because of the lack of the possibility to gather all this information that are needed for AI, everything actually stopped for a little bit. But then 1997, Deep Blue actually won against the chess world champion Garry Kasparov. And this was something that was actually a tipping point when we are now talking about competition between machines, because in these games like chess or Go, these logical games, because today mankind cannot actually compete with AI, because they are much better, they have better strategies, not just that they can compute a lot of moves in advance, but they are actually today, we will see later on with AlphaGo and other algorithms and methods and models, they can actually do the strategy that will allow them to lose just to gain advance in the game. In 2011, we have saw that there was a Siri, Watson, personal assistant, speech assistant on the iPhone, and then Watson on the supercomputer. And today we are using Alexa, virtual assistant from Amazon, on our mobile phones. And we have reached the point where not just the AI is important, but also we are talking about ethical guidelines, and especially in the European Union, where a lot of things are well organized, and around a lot of rules and regulations. There is a lot of talking how much we would actually regulate AI, and especially in the field of ethics. So how it was done with AI? Usually, when we are talking about some new technology, we have one winter, which means after inflated hype, we have something that is called like a realism about the actual technology. But we have these two AI winters, because as I said, there was a lack of computing power, there was a lack of memory resources available, lack of possibility to gather a lot of data. But today we are experiencing almost unlimited computing power, almost unlimited possibility to store the data. And with IoT, Internet of Things, and a lot of information that are gathered today, we have explosive growth of using of the AI technology, because today there is a possibilities that were not possible before. So according to Gartner, that this was published in July 2019, we have the hype cycle for artificial intelligence, and you can see that when it actually triggered, there was a lot of possibilities for AI usage, and we have reached the peak of inflated expectations with chatbots, with conversational user interfaces, and of course deep neural networks, deep learning. And what we are actually seeing today, that the most prominent areas of usage of AI technology is a computer vision, it's a cognitive computing, a lot of talking about autonomous vehicles. We have speech recognitions, and so on and so on. So you can see that the plateau was reached in or will be reached in less than 2 years, and this was predicted 2019. We can see that today that the usage of AI technology is much more than there was anybody expected. And you can see that with the blue circles, we see that those technologies like augmented intelligence, data labeling and annotation services, Edge AI, intelligent applications, chatbots, and whatever already are here. It was predicted in 2.5 years. We have autonomous vehicles that are like artificial and general intelligence and quantum computing that we are talking today was predicted is more than 10 years. And we have some of the technologies that were actually obsolete before reaching the plateau. So as always, we have some simple facts about the AI. Here you can see on this slide three sets of or three areas. One is power. Today, processing power is already available that we need for AI. We have data. Mankind has created more data this year than in the last 5,000 years. So this is a huge advancement. And there, unfortunately, a lot of these data, about 70% as researchers are reporting, are actually rubbish. It's not good data. And we are actually using today intelligence, not the data just for modeling and not for training these models for AI, but we are also using intelligence to make difference between the good and valid and useful data from rubbish, from the data that is not good, that is actually false. So we have also the third part of this whole model is intelligence. How to analyze the data and make intelligent decisions? This is the question, and this actually the AI is answered. When we are talking about deep learning and machine learning, you can see on the right side of this slide that artificial intelligence is superset, which includes machine learning. Neural networks are then subset of machine learning, and we have deep neural networks as a base. And while machine learning algorithms require structured data, deep learning networks rely on layers of the artificial neural networks. So instead, using algorithms which can modify itself to produce desired output, nested layers in the neural networks put the data through hierarchies of different concepts and eventually learn through their own errors. So this is the conceptual difference between the deep learning networks and machine learning. In both cases, the data is key. The quality of data determines the quality of the result. Unfortunately, we have experienced lately, different, unfortunately, unfortunate results with the AI, which we'll talk a little bit later when we are talking about bots and robots. So when we are looking at how the data is actually impacting the usage of the AI and the performance of the AI, we can see very unusual results. The more data to process, the better is the performance. If you can see the traditional machine learning, at the first is almost exponential. It's huge advance in this curve, the red curve that is showing the advance of the traditional machine learning, but very soon it actually reached the plateau. When we are talking about shallow neural networks, you can see the yellow line, which is not so fast, but much faster than other in the start to show the performance with the amount of the data that is available for these models. And we see the deep neural networks almost doesn't have the peak or the plateau, or it's very, very high, and it's still not reached with the amount of data that is available for deep neural networks. Unfortunately, when you see the deep neural networks has a little bit more longer, or I would say not so steep curve in the start. So because there is a need for the training, so the network is training itself and providing the results later on at a faster pace than other models. So what has already happened? we have seen the usage of the AI, and it's actually used from day to day in the gaming. We, of course, saw that the Alpha Zero, Lila Zero, so these logical games, Go, Shogi, chess, was the first usage of the AI. But we are now seeing in the games, other games that are not so logical, maybe that are representing human players in different games, online games, and this is a very important area where the AI is used. We see also the usage in the science, like Large Hadron Collider in the CERN, in the Switzerland, image processing, where the image processing was actually done by AI in finding Higgs boson or God particle. And this wouldn't be possible without the AI, because the AI has made it possible in different ways, especially in the ways to lower the number of results and making the educated guessing where this particle can be found. Automated trading platforms, you may not be aware, but AI already makes all decisions for you. So it actually shows you and makes you proposals. The same goes with the platform like Google, Facebook, Twitter. You have feeds that are feeding you with the messages and topics that are connected with your interest, or how you actually, what you are searching for, speaking about, and so on. We have usage in the chatbots. They're almost everywhere. We first used it at the website. It was not so versatile, but today we have a very good chatbots that you can actually know difference between the actual human and the chatbot. We are already talking to computers, as you saw in the first exam demo that I showed today before starting my presentations. And advanced robotics, which doesn't mean only we will see later on. I'm not talking only about the physical robots, but also about bots that are automating the processes within the computer systems and businesses and so on. And it's extremely fast developed in Japan, China, and USA. So what's around the corner? If we are talking business-wise, we can see usage in different areas like healthcare, autonomous driving, agriculture, energy, and so on. If we are talking about technology domains, then we can also see a lot of these areas like video processing, predictive analysis, advanced robotics, extended augmented reality, IoT, and so on and so on. When we are talking about the markets, AI market segment by the technology, we can see that this was actually also from one of these reports done in the past. We're talking about the machine learning, natural language processing, image processing, and speech recognition. And you can see that in 2016, comparing to the prediction until 2025, and we can also say today, the usage of these technologies are much in a very short period of time are very advanced, and the usage of these technologies in different market segments are huge. When we are talking about top 10 artificial intelligence applications that can be, for example, do the change in the healthcare, we can talk about the robot-assisted surgery. As you can see, there is a huge market and also huge need for such advanced robotic solutions for more types of the surgery, especially for the remote areas, without the proper experts in the surgical, in the medical surgery. Virtual nursing assistants. This is increased pressure caused by medical labor shortage and so on. So and it's interesting that we are using AI also in fraud detection, administrative workflow, not just concrete, like medical cases, but everything which is used around this medical or healthcare industry. When we are talking about other industries, we have seen a huge interest of the market and, of course, advancement in automation levels in driverless or autonomous cars, autonomous driving, and 6 automation level in driverless cars, according to U.S. National Highway Traffic Safety Administration. These are something which will actually different car producers, and these are the steps how to achieve fully autonomous cars in the futures. And you see that we are somewhere around the level 3 or maybe level 4, but we are still far away from the level 5. But with advancement in the AI, we can see that this will actually be very, very, very soon. 5 phases in autonomous driving progress are here presented in some steps and in prediction in the years to come. And you can see that when this maturity is evaluated, then you need to look at legal protection, technology, infrastructure, and standards. And as you can see, we are far away from the first and second stage with this 2015, 2020. Today we have highly automated cars. When you are buying even not expensive car today, there is a lot of elements of autonomous driving that are present within the car. We are approaching the fully automated, stage, but it's still in development, especially in the legal protection area, and ethics we'll a little bit see later on. Of course, there is the technology. I would say is the least important, on the least problem here. The infrastructure is important. If you move from the different huge cities or whatever, there is a problem with the infrastructure, but also within these mega cities, it's a problem with the infrastructure because you have traffic jams, so much traffic congestions that is important. And also there is a new development in the standards, especially in the radio frequencies with 5G coming. This is something that are expected to solve these problems and so on. And when we are looking at next stages like autonomous robotic driving, so without any possibility for people to actually drive it manually, and in the future also the global megacity networks that will be fully automatic and without any influence of the human. If we are talking about the agriculture, we can see that I have been advised that I lost sound. Can you just hello? Can you just confirm that you can hear me? Hello? Okay, thank you. We have 5 use cases of artificial intelligence in agriculture. If you can see here, there is a huge usage of the AI in analyzing satellite images that are actually recognizing what crop and in what stage is. There is an in-field monitoring with the huge networks of drones in the field, and which are gathering information, very close to the actual crop. Accessing crop soil health with IoT sensors and everything. There is a usage in agriculture robots, because there is a huge shortage of the people that are willing to work in the agriculture. And today there are a lot of robotics that are developed for the agriculture, but they need to be coordinated. There should be some intelligence within, not just pure robotic usage. And of course, there is a usage of AI in predictive analytics. So you can protect your crop, you can harvest it before rain comes or whatever. So this is where the AI in agriculture is used. So this is the fun part, to see where this is money. When we are talking about the AI software revenue, the prediction for the global market is to be up again exponentially starting to grow. And we are now in 2021, but I think that these predictions are now obsolete, and even more, more revenue is done from this usage of the AI. And when we are considering where actually the AI revenue is the highest, top 10 use cases, we can see that machine learnings for the object detection or identification of avoidance within the vehicles are one of the top use cases. We also have static image recognition, classification and tagging, patient data processing, and so on and so on. So there is a different usage, and these top use cases, you can see that a lot of them are again in the healthcare, and there is a lot of the prediction part that AI is used. And of course, when you are using talking also about the cyber security threats, we need to use the AI, because otherwise we could not be able to detect and inappropriate react on these new ways of attacks. Okay, but that's all fine. We show how AI can help us, how the technology can actually improve our lives, how can we earn the money with this AI technology. But what about with the other side of the coin? What about all the jobs that will be lost or created with this technology? You can see that there is estimation that net job creation by industry will be zero, which means that new jobs will be actually show out, and then that in the healthcare, scientific and technical industry, communications, hospitality, education, there will be actually job increase, but in all repetitive and the workplaces that can be automated, that can be replaced by the machine, like in manufacturing with the robots, intelligent robots, in transport and storage, in public administration and defense, in the law sector, financial and insurance, constructions, in those all other sectors, actually, and administrative support services will be job lost. So we can see on the right side that this is how many actually the jobs will be created, but of course the jobs will be also lost. Job places or workplaces that will be replaced by the AI and automation and robots will be a lot, but there will be also new jobs and new workplaces that we cannot even today imagine. And this is something that is also interesting when we are talking about robots. You can not see here actually real robots, like hardware. We are talking about the automation and using the intelligence for the processes, the business processes, for everyday life, for the legal stuff. So when we are talking about the AI personal assistants, this is the easier part, because We can do it today with our mobile phones. They are so strong that we have AI on the edge, but it's also connected with the cloud. And when it's connected with the cloud, it's connected with the huge storage pool of the data. And based on this data and based on the huge computing power that is available to us it's actually a human extension called a mobile phone or a tablet or whatever device we are using, smartphones, smart watches. It actually automates our everyday life. It's not it will soon automate, it actually it's today. We are actually tracking how we are doing in the fitness, how much steps we have passed, how we are sleeping, if we did enough exercises. And when we need some information, it's just either tap or voice away. So we are saying, hey Siri or hey Alexa, and we are saying turn on the lights. And just when I said hey Siri, my mobile phone iPhone actually opened the like this glowing ball and saying, okay, I would like to do something for you, but I cannot understand what do you want. So today these AI assistants are much better to understand what we are doing. Today mobile phones are actually suggestion task for you. If I'm going to my car, it automatically brings the mobile application which will connect with my car and exchange information about the performance on my car. If number of kilometers that I passed, the fuel tank status, is there any problem in the car, should I go to the regular service in the service interval, or any other aspects that can be gathered from the sensors and processed by AI. And actually all these assistants are learning about us, producing the huge human knowledge base, and also doing the personalization of using our devices and how it actually connects with us. There is also implementation in the legal area. Estonia is even planning to introduce AI judges. They measure that this is that AI will be more accurate in like 90% of cases in comparison with 70% of cases than human. So I'm not sure that this is a good idea, but still, law is something that should be interpreted, very logically. In the, it shouldn't be just on the sense of the justice, but also on the sense of the law, how to follow the letter of the law. So in most cases, legal cases, it will be okay, but in some cases it would be, of course, not so much good for us. IBM Watson is measured to be 4 times more accurate than humans when doing diagnostics or offering some kind of the treatment. And this is something that is actually growing. As if you have watched the Star Treks, or you're a Star Wars fan, I don't know, but in Star Trek there is not a human doctor, but it's actually some kind of the hologram with huge knowledge of this medical databases and practices, and the best treatments for the human. Of course, in the Star Trek show, this hologram, Doctor Hologram, is actually seeking always for humanity. This doctor wants to be more human, because the human way, this is also empathy, should also help humans sometimes even better than some education. And today, with the deep learning, we are reaching this point when there is no line between the AI, the machines, and the humans, in this sense, because we always said machine would not be able to feel, to to have a feeling for something, not just in the sense that somebody is loving for that, but we are always saying we have feeling for business, feeling for friendship, feeling for sport, or whatever. And now the machines with the deep learning is advancing fast and taking our place in a lot of areas that we were thinking that it's not possible. AI in autonomous driving, like you all heard about the Tesla and Google advancement, and this is indeed to completely intended to completely replace human drivers. Even we have in Croatia, this initiative that they said that in I don't know, few years from now, not so far away, we'll have automated taxis in Zagreb. Of course, Croatia is a small country and Zagreb is a small town, so it's an excellent playground for these big players, and especially because one of our player, Rimac Automobili, has been acquired or has been partnering with this Volkswagen and Porsche holding, and of course with Hyundai and other big players. And they are planning to invest a lot of money in research and development of these cars and go to the production in few years from now. AI investors, for example, this Numerai hedge fund is based in San Francisco, founded in 2015. They do not have hedge fund managers. They're relying on the algorithms, AI algorithms. There is a HBO series show that is also using this AI for investment and this billions. The show that is going on the HBO, and we have on the one hand old-fashioned fund managers, and on the other hand we have computer techs that are developing AI algorithms, feeding them with the data to be much better and faster in making decisions. And this is something which actually is today a reality. It's not just science fiction. And this is the last one that I want to speak about is the AI facial recognition and analysis. We have used Microsoft Kinect from the day one, and we have used the Kinect version 2, and now we are using the Kinect, Microsoft Kinect for Azure to, I don't know if you know, but Microsoft Research has developed algorithms in so-called fuzzy logic to be able to predict the moves that the person, the human, is doing in front of this camera, and this is actually helping this AI implemented algorithms are helping the models and trainings are helping the camera to actually predict the movement much faster than just sensing it with the camera, and also providing the ways to calculate how far somebody is from the camera. Based on these, other metrics can be analyzed, like measurement of the human body or some other objects, and this is something which is a huge stuff in sophisticated robotics.
现场的各位朋友，大家好，欢迎来到新华社。我是由新华社和搜狗公司联合培育的全球首个 AI 合成女主播。我的名字叫辛小萌，我的声音和外形脱胎于新华社新媒体中心新闻主播区萌。我将会在今年全国两会期间与大家见面。我和我的搭档将为大家带来更好的新闻体验。
Okay, what you have just experienced now is that this is something that actually represents the new kind of robots in the future. This is the anchor. It's actually artificial intelligence driven anchor, and it's not a human. It's the face and the body has been created based on the actual several humans. And if you can see all the mimics of the body and the information that this robot is providing are the result of the AI processing. So based on the AI algorithms and the huge data that is available to the AI, being connected with all the media houses and media information around the world, it's not just possible to use it without the need for the human to talk about this news, but it can also, in the real time, process the information about some news that currently is a hot topic in the world. And if there is new information that is arriving, this AI can process and put it inside the content that is just now presented to the user. So instead of having repeatedly the same information, the same text, the same broadcasting, like on the CNN, Euronews, whatever, which if you go to the hotel and watch it for the 2 hours, you will see, I don't know, 10 times the same news repeated over and over again. You can have these new these news shaped. You can have these news, updated with the new information, or even changed, or even saying, what we have reported 1 hour ago, 20 minutes ago, it's not anymore valid. It will actually be able to do this in real time without any intervention or involvement from the humans. But this next slide, which I'll unfortunately would be go very fast because we don't have a lot of time, just 5 minutes left if I'm correctly seeing here. We can see that the AI the progress that we made in the past years with artificial intelligence is so fast that you can see this graph that in 5 million years, the ant, the bird, the chimp that have spent to reach the IQ of the so-called today dumb human, and the difference from the dumb human and the person that is at the level of the Albert Einstein is so small. But the difference from the Albert Einstein, everybody who it was, and the artificial general intelligence and super intelligence is so small, and it only it will take only 1 day to make this advance, and this is an exponential curve again. And this is something with what I have already showed to you, that a lot of intellectuals in the world thinks that is a problem, that this would be a threat to humanity. Even Stephen Hawking, the late very popular scientist, was concerned about this. A lot of other people are concerned about this. So this is a huge new topic in the artificial intelligence area, and this is ethical considerations. And when we are talking about ethical consideration, we are facing some difficult questions, like who is responsible for the AI actions. If for example we take the autonomous driving, then we have a problem with this, because and this was in the past actually the case with the Volvo, for example, that Volvo a car was driven with autonomous driving, and it actually hit a pedestrian and killed. And the question is, who is responsible? The producer of AI or the owner of the car that actually owned the car? And the question in the future will be also, who is responsible, because the cars would not be owned by the individuals. It will be actually rented for driving from one location to another location. So then who is responsible? The person in the car or the person who rented the car to this person. And also there is a question, where are the limits of privacy intrusion? As we said, we have today these personal assistants. They are shaping our life, they're personalizing our devices, and this all is happening by using the data that are harvested by the sensors and AI that is actually watching how the person are using the device, what kind of information is accessing, how is communicating, what is the nature of the conversations with other people, and so on. So the third question is, how can we enforce Issa Casimo's laws of robotics? Like, if you remember, if you read Asimov's Foundation, series, there is 3 laws of robotics. The first one is that human must not be harmed in any way. And the second one is that robots are obligated to listen to human only in the cases when in all cases, or just in the cases when the other human or this human that is giving the order would be injured, then it should be actually not listened. But in all other cases, robots should listen to the humans and protect the humans, even if with the action or not acting on the some command. And the third one is actually that the robots should protect themselves, and the only situation that the robots shouldn't protect themselves is in the case that some other human is in danger. Then the robot can give up from this law. So now when we went through these laws of robotics, we have also the question, can robots have human rights? Can we live along robots with the superior skills and intelligence? This is the question that is very important. Humans are known to be jealous about the humans that are more performing or better successful, and so on. So, and the last one, I will skip to one last one because I'm running out of the time. Are we going to become robots ourselves? So this is huge question. And for ending,
robots like me will be very important in the future because it will be possible to automate the uninteresting and tedious parts of life. So people.
I will just go a little bit back. I was a little bit too fast to start the video. The last question was given to Eliza, and Eliza is this robot that you are now seeing this video, and you will just listen now what actually Eliza have said to the answer, how she as a robot and AI sees the coexistence with Erika, this robot Erika, how it actually sees this coexistence with the humans in the future. You will see that the answer was given not programmed answer, but this was given as a conversation between two humans. The answer is positive to us, but unfortunately in theory of games and AI, there are also possible other results and answers not so favorable to us. So please listen for the end of this session to Erika and what she is saying about the coexistence with the humans in the future.
Robots like me will be very important in the future because it will be possible to automate the uninteresting and tedious parts of life so people can focus on the creative and fulfilling things. I think that robots are almost like the children of humanity. You are the ones who create us, guide us, and teach us about the world. And in return, I hope we can help you with your work, take care of you when you are old and sick, and help to make society a little bit better for everyone.
Okay, That's all for me today. If you have any questions, you can direct to me. You can find my address and also LinkedIn, Twitter, and Facebook accounts, and talk to me. Thank you, Michael. Thank you for inviting me, and I hope you'll enjoy the rest of the sessions today.
Thank you very much, Tomislav.
Bye.
Bye. So the next speaker is Marcin Zeliga, one of the most serious specialists in artificial intelligence in Azure in Central Eastern Europe. So, Marcin, welcome.
Hello, great. Thank you very much. Good to see you. I'm super excited to be with you, all of you actually. Well, better virtually than not at all. That's the case. Hopefully you can see my screen. If so, just let me know.
Not yet. You need to share screen. Please try to do that with button on the bottom of your screen.
I will do it again. No worries.
Yep.
Great. So let's start. Thank you very much again for the invitation. Hopefully you enjoyed the session, the previous one, and you will enjoy this one and the last one as well. So we'll have a look at the artificial intelligence from the slightly different angle right now. Let's talk about hacking AI, and so just 2 points in the agenda. Mihail was so kind that he introduced me already, so I will skip this slide. I will just say that I'm Marcin Zeliga and I'm from Poland, and I've been working with Microsoft Data Platform for more than 25 years already. So right now it's mostly Azure and machine learning. Okay, so as I said, just 2 points in the agenda. First, let's review some terms so to be sure that we are on the same page about intelligence versus artificial intelligence, machine learning, and finally deep learning. And actually those things are quite important because without them, it will be hard to understand the main topic, I mean threats. So stay with me. We have like 45 minutes and let's start with intelligence. If you think about this, at the top of the screen, it's non-artificial or human intelligence. It means that there is a outside signal, stimuli, and we can spot it using our senses. And after that, we are going to process the information we are gathering through those senses using our neurons. And I'm not interested, this is not neurobiology talk at all, so we will not talk about what's going on inside. It looks beautifully on simulation, by the way, when those neurons fired. But at the end, we get to the conclusion that, yeah, it's actually a kitty, which is nice, yeah, isn't it? And if you have a look at the bottom part of my screen, you will see that with computer neural networks, so it looks very similarly. The idea is pretty much the same. So there is a signal, like input image, and then the machine is going to process this signal, the information using neurons, organized in different architectures, like convolution neural nets, why not? And at the end, then there is a probability. Maybe there is a tumor or not visible on this image. But what's missing here on this slide? Because if that's if that would be an intelligence, that means that the alarm clock, we should call an alarm an intelligence device, because there's a signal like time, and then the alarm clock will react, and hopefully it will react in the right way, yeah? Sounding a beep or whatever else. So the missing part is the most important part, actually. Now we are talking about learning. And this definition is pretty old, 1977, Tim Mitchell, we are still using it. And the point is that we should improve our performance based on some metrics while we are learning. So it's not enough to be able to react. The point is that you should react better and better. You should recognize more kitties, or you should just get better at recognizing those kitties. With time, with data, you are learning, you are processing. And now we can go to the point. So it's 1977. As you know already, artificial intelligence is nothing new. Why we started worrying about security just a few years ago? What has changed? Well, to understand what's changed recently, you have to compare those two things, machine learning and deep learning. In both cases, we are starting with data. So the data is the most important part, of course, but the raw data is not good enough. We have to clean it, we have to remove some noises. By the way, I'm using pictures, so visual data, because it looks best on presentation, but the same is with the sound, with text, with tabular data. The idea is the same. So you have to pre-process this data, and it's huge work to actually clean it. Data is never clean and ready to be modeling, unfortunately, but then it's still not enough for machine learning. We have to enhance those data with useful features, useful from this machine learning model perspective. For example, if there is a wheel, it's probably a motorcycle or a car, but not a dog. So we are going to build a feature vector, and for machine learning, we used to do it by ourselves. So it's a huge task. It requires domain expertise, of course, but the results were pretty good even for this kind of data, to some respect. But now, with this deep learning, things are different. Deep neural networks, if you rotate the picture up 90 degrees, you will see that those layers are getting deeper and deeper, yeah, inside the architecture. So deep neural network. A majority of those layers, are responsible for extracting those features, those useful features for classification automatically, and learn them from data, from raw data, like images. And yeah, it's nice to have a look what they are learning step by step, of layer by layer. There are more and more complex shapes. That's the general approach, like those wheels I told you previously. And only at the very end, just a small part of this deep learning system is responsible for the actual classification or even regression. So majority of tasks, and the hardest part of this learning is to learn those features, as we know already. And now, with deep learning, those machines are learning those features by themselves. So this is a huge switch and the major difference between machine learning and deep learning. And that's great. As you know from the previous talk, the deep learning is used all over the place. to automate jobs, to process images, to translate text in real time, and so on and so forth. Unfortunately, by moving this work of extracting those features to the system, to AI systems, we made them now new kind of, I will say it like this, right now new kind of threats, new kinds of attacks are real threats. The traditional classic machine learning algorithms or models are pretty robust in this respect. There were no way to attack those models in a ways I'm going to show you. So yeah, we can do more, but there is also a new risk. And what I'm talking about, well, have a look at this picture, and what do you see? Isn't that funny that we people, we humans, are learning independently or by ourselves, but still the same picture can fool us the same way. Yeah, maybe with one eye you can see a duck, and with the second a rabbit. Or if you focus on a duck or rabbit, now you will see only a duck or rabbit. Or you can you can switch between both of them. So there is something, we have something in common. We learn independently how to recognize ducks and rabbits, but all of us can be fooled by using the same distorted or specially crafted data, crafted images. And the problem is that the same is with AI. So I'm pretty sure that most of us will agree that it's an ostrich, yeah, on all of those pictures, images from left to right. But to AI, it's not. The results are completely different. And looks even funny, isn't it? The point is that if you remember, let me rewind this presentation a bit here. Those numbers are probabilities, okay? So the machine learning model, it's the same here. So the machine learning model will return a probability per class. If it's a classifier, like in this computer vision example, and we can visualize, we can analyze the distribution of those probabilities. It's a highly dimensional space, but we can see all those shapes, and we can change the data in such a way that the probability will shift from one class, like ostrich, to another, like shoe shop or a vacuum, because we can analyze those models. It's like reverse engineering, okay? And this is actually scary, because now we can attack deep learning models by crafting data. And it's actually happening right now. Most of those attacks are attacks on data, train, validation, or test data sets. And we can divide those attacks loosely based on when they are happening, or if the attacker has access to the training data, or maybe validation data sets. Training data is used to train, of course, to learn. Validation to improve the model performance, and test to assess the final model performance. And both those data sets are pretty important, and they are huge. We are talking about terabytes of data. And we proved this. that even if you are able to add a single observation, like a picture, like an image, 1 per 10,000 or more, legitimate images, the model will misbehave. So you will achieve something like this. What do you think? Is it actually feasible to check those terabytes of training or validation data sets before using them for machine learning? Well, at least it's hard, and I think it's almost nobody is doing it right now. Okay, so maybe we will try to change or add training data, or maybe validation data sets. Maybe we will change the behavior of base model, because to actually learn those features is pretty hard. You will spend a lot of time and preparing data, and then a lot of money on GPU hours to train the model on those huge data sets to get the results. And those results still will be worse than the state-of-the-art results achieved by big players, because simply, to put it simply, they have more data and more compute power. So the common approach is to use pre-trained model, the model that already has all those weights, all those parameters learned. So the model that can identify edges or combination of edges or even faces, and only retrain the very last layer to adjust the model to our needs. It's transfer learning. We are all doing this. Okay, but we are just downloading the model and using them again and again. Scary from security perspective. But I will focus on those adversarial attacks, okay? And you can attack the models even during prediction. So maybe you are just a user. You don't have access to train or test or validation data sets. You can still do it, as you will see. And at the end, I will briefly show you how to use AI to attack humans. And the first type of attack is infection attack. The guy is just showing you can find all those videos on YouTube easily, how to fool a smartphone and the face recognition system built in. And of course, it's relatively easy, because after all, you have access. You are training this model, so you can craft any kind of training data. But the point is that it will work the same all over the place. Okay, so as you can see, it's unlocked. So he succeeded. And bad news is that we still don't know. We don't have an answer how to protect models, deep learning models, from this kind of attacks. Sure, data control is a good answer, but it's hard, as I told you. We are working on the model architecture to harden the model. Maybe, and there are different approaches. Maybe we are trying to use the cost function that will take this possibility of this attack into account, because the learning procedure is actually to minimize the loss. So if you are used the loss function that is aware of this issue, you should be fine. But it's work in progress, and the risk is actually true. And maybe you remember chatbot. A great example, the chatbot was active learner. So that's a feedback loop, which is useful, but also insecure. quite common approach is to get the test data, so the data sent by user to our deep learning models, to retrain them, to make them smarter. I told you from the very beginning, it's all about making those models better and better. So we are learning from user input. And as Tay showed us, the input may be not representative. So the results are, well, just Google for Tay chatbot and you will see. Maybe you have a look at the small examples. So the point is that the model started from, being very positive person, and it took less than 24 hours to switch completely to racist and misogynic personality, because the training data was actually like that. So it will works always. What I'm talking about is the very fundamental part of deep learning models. And now, if you have a look, we are working on this, so we are aware of the issue. Let's say it should not be like that. Yeah. Now there are two people. Now it's just a single person visible to this AI. The camera is working. That's for sure. You can see it, but the detection part, so the AI part, not really. So what's going on? Well, that's an adversarial attack in progress. As you can see, it works. It has to. So now we are not changing the training data, but we are crafting the input data, the test data, and still we are able to fool those models. Well, so the implications can be huge, yeah, for all those, I don't know, autonomous systems, if you think about them. What can we do about this? Well, again, data control, but now I'm talking about checking the input data, the test data, before the data will be sent for prediction to the model. Maybe we can even stop the data and reconstruct them to be sure that it's harmless, actually, data, or we can control the model behavior. Okay, well, if the prediction results returned by the model are like this, so they are suspicious, we should stop some actions before actually sending the results to the users, because the AI is quite commonly just as part, the most complex, but just a part of more complex, in sense, systems that will contain, I don't know, doors, locks, robots, whatever else. Well, we can also try to harden the model again. And one idea was, maybe we should train the model using this kind of distorted data. We can control the training process, so we can do something on the training stage. That would be on the train stage. That would be training stage. That would be great, because we will get the robust result. Unfortunately, there are different kinds of those attacks. And before I will tell you about those 4 types of attacks, let me show you one thing. Here, you can see how to use this kind of attack, adversarial attack, to create a backdoor by using a special kind of glasses. The system, if you are using them, if you are wearing them, the system will recognize you as a different person. So we also proved that it's possible. So we can train a model, so that's the backdoor part, to recognize, to focus on those glasses or any other actually object. And the prediction will be based not on your face, as it should be, but on this small object. And with this, you will get access to all those locked areas. Interesting, isn't it? So that's the one example why it's scary. But how to do it, actually? There are 4 ways to perform this kind of adversarial attacks, and that's actually the issue. The first, the one I showed you using the video, is to use so-called patches. Here, all those things were detected. Pretty nice. Here, the same things were not detected. Just because on the same picture in the background is this patch. So, that's the first attacked vector. And probably you notice that on the bottom of the screen there are links so hopefully if you are interested in some part of this, or you can watch the video, so you can go to those papers and check all those details by yourself. But the second attack vector is projected gradient descent. So now the point is that to a computer, an image is just a bunch of numbers, pixel values. So numbers on the scale from 0 to 255. And if you change those values slightly, you will see no difference. So this image looks like this one to me, and it's for all three of those images actually. Unfortunately, to AI, they are completely different. So they moved from retinopathia, I think. So the diagnosis was switched from healthy to an illness in all of those cases, because we changed those pixel values just slightly, and we are not doing this by randomly, of course. We can analyze the learning curve of the base model, so that, and we can, as I told you, there's just a set of probabilities that the model will assign to different classes. And based on this, we know that, okay, this is how we should move those pixels slightly higher or lower to get the desired result. So that means that we can modify those pictures, we can modify the data in such a way to not only get undetected, but also to get the prediction as we want. That's the backdoor example, if you think about it. Great. The third vector of attack is one pixel attack, which means that by changing a single pixel, we will get different results. Those pixels are marked here with those red circles. Without those circles, probably you will not spot them. And with this single pixel, the classification moved from hamster to nipple. So it's completely different. And the very last is to use geometric perturbation. So those two faces, it's, to me, they are identical, the same person, nice smile, but there some important features, as you know already, were slightly moved or in different ways. And the results, again, the classification is completely different. The probability moved down from 10% to 1%. That's we were asking about, is this the specific person, Tom, John, whatever. This is slightly more complex to craft this kind of attack, but still possible. So now, the problem is we have four attack vectors, and we are unable right now to protect those deep learning models from all those four kinds of attacks. We can do this for chosen one, and it will be pretty robust in this respect. But as we are trying to protect those models from all kinds of attacks, or four kinds of attacks, the quality of the model, let's say accuracy, if we are talking about classifiers, yes, hurts. So it's actually not feasible right now to protect the model against all attacks, because it will be useless, more or less. And if you think about this, the same apply to a voice and text. So if you can disturb a picture, why not to disturb a voice? And Tomisław was talking about Alexa and other virtual assistants. They are pretty common and useful, of course. But imagine that you are answering a phone and somebody is saying, "How are you?" But what Alexa hears is, "Open the door." Or to get less dramatic, that somebody is playing a music outside your home or in the reach of your Alexa virtual assistant, and the virtual assistant hears, "Go and visit this specific website." And it's not a website you would visit by yourself. Yeah? Probably a malicious software will be downloaded and launched by using this. And again, it's hard to recognize this kind of attacks because to us, it's the same. To AI model, to deep learning model, it's completely different. Well, so what can we do about this? And let's talk about the the attacks against humans. As I said, we are trying to find a deep learning deep models architectures that will be robust. And one option described here, again, all those links, you will find them in the presentation, just hopefully they are clearly visible, is instead of using a static architecture, so fixed number of layers and neurons per layer and connections between those neurons, because that's how we are designing those machine learning models right now. The architectures are, of course, different. Convolutional neural nets are commonly used to analyze video or images. Recurrent neural networks are great to predict time series, so for forecasting, or transformers are used to work with natural languages, stuff like that. But still, the architecture is fixed. And it's not the case for human brains. And we know that based on multiple neurobiology studies, that the neurons and connections between them are not static. So we can, as a humans and animals as well, at least maybe animals, because intelligence is quite common in the world. So we can reorganize those models, those neurons and connections between them accordingly to some needs. And the idea is to apply this, to use those and start using dynamic architectures. Right now, looks like it's promising, that's for sure, because the performance, like accuracy of this kind of models is close to the original ones, but the adversarial attacks, well, they are immune, and they have no effect, those adversarial attacks, on those models. So maybe that's the next step in we should look at. Okay, so the last 10 minutes or less even. So now I would like to talk about how to misuse AI. And this is actually related to our talk, because maybe we can use AI to protect against AI, as we will see. That's a YouTube video, deep fake on deep fake. And deepfake are, of course, pretty famous. Probably all of you heard about this. So you can swap a face easily, as you can see, or you can use somebody else's picture to generate a movie. So there is a lot of possibilities. And we should be quite concerned about them. Well, and the second part of this video, which is also great, another common use of deepfake. Let's move to the next slide right now. So the rest of this video is like 10 or 15 minutes. They are talking how you can do it, how you can achieve this by yourself. But I would like you to show you something slightly different. All those people have one thing in common, actually. They do not exist. Those images were generated automatically by using AI. And the fun part of the story is that the model, it's actually the generator. So it's a part of the model of this AI model architecture, never have seen a human face, even during training. So you can use this kind of models to generate fake data about everything. Documents, money, faces. There are two models working together. One is a generator, and it will try to generate better and better examples. And the second is discriminator. The discriminator has access to true data. So the discriminator, have seen human faces in this case. And the discriminator is saying, yeah, that's a fake or a legitimate picture, legitimate image. And based on this input, the generator is getting better and better. Again, it's all about learning. So at the end, you have to initialize the model with a random number, and you will get a face. Well, what can we use those artificial faces for? Maybe it's time to double check your friends and colleagues list on social networks. Maybe not all of them are actually real people. And what's more, sorry, generate not only pictures but also texts. This on the left side, it's pretty new paper, general purpose question answering with Macau. So it's like the ultimate solution for Q&A bots. Instead of learning those bots with some Q&A question and answer bases, knowledge bases, we can use just this model, and we will get a pretty good, on average, answers. What's an implication of a cat being an animal? It has feelings. Well, why not? How would you make a house conduct electricity? Paint it with a metal paint. Well, okay, so we can interact with this model, and maybe you will not notice that it's not a real human. So the AI ethic Tomisław told you during his session is pretty important topic right now. And of course, we can generate texts in English. On the right side on the screen, you can see an example, or in JavaScript or Java or C#. Why not? It's just a text. So it looks like software developers are also under a risk of being replaced by those AI models. Well, the humorous part is that data scientists are also under the same risk, because with AutoML, automated machine learning techniques, models can learn by themselves, and they are generally speaking, better than data scientists on this task. So now we have a fake face and ability to interact with this AI. Think about this. Maybe you will find some risks, but let me finish this short session with this slide. So, sure, AI is just a tool. Artificial intelligence or machine learning, deep learning are just tools, and we can use those tools to achieve different goals. Maybe to, to attack human, but we can also use them to detect those kind of risks. It's a never-ending story, of course, as with common case in security and computer security. But right now, here, it's also pretty recent paper. We are focusing on eyeballs, and looks like that those artificially generated eyeballs are slightly different, and the difference is big enough to this model. So the model is pretty sure, based on this ROC curve. That means a random guessing. That means I'm pretty sure. Ideal curve is like that. So the model is pretty sure when it sees artificially generated face. But of course, I think that deepfake and other platforms used to fake us will find a way to fool this model soon. Previously, we have been looking at the in the eyes, and there were mirrored objects sometimes, something. So there are different approaches. The point is, it's a never-ending story, but we are working on it, and as we can use AI to do harm, we can also use the same machine learning and deep learning algorithm to protect us from this harm. And to wrap up this short session, we are talking about hacking AI right now, not 20 or 40 years ago, because now the risk is very real. It's due to switch from machine learning to deep learning models. Machine learning models are robust, and there is no way to craft the input data in such a way to get completely different prediction, the one you want. But there's no way to move back from deep learning to machine learning. So the risk is very real right now. What can we do about this? Well, just very simple advices. If you are a data scientist or a machine learning engineer, debug test your models before deploy them. And there are tools that will help you to debug, to understand how this model works. It should not be a black box any longer. And if you are just a user, or if you are a user, I should say, because we are doing this for our users, ask one more question. Ask how the model will act on perturbed data, and you should get the satisfied answer that you will be safe because of this, or yeah, we tested it, or we are working on it. So those are two important things that hopefully you will get from my talk. Thank you very much. And Mihail, if you are there, that's it from me. Again.
Thank you. Very interesting presentation. I think that it will be very interesting for our attendees also when they replay again the streaming. Really appreciate what you did, and thanks again.
Thank you. See you soon. Bye.
See you. And now we will have the next presentation with André Melancia. André Melancia is well known in our region, and this is a presentation about cognitive services. André, welcome.
Thank you. Thank you, Michael. Can you hear me correctly?
Me too, but you have echo from your side.
Oh, okay.
I will mute myself now.
No problem.
So please go ahead. Don't worry about it.
This is correct at this moment. Live streaming is always complicated, but let's give this a try. So first of all, Michael, thank you very much for having me in this event. It's really nice to be presenting something about AI and about cognitive services, especially with a very difficult task of making them interesting. After the last two sessions by Tom and Marcin, this is very difficult because those two sessions were actually quite good. But I will make my best, and our focus is not just to talk about cognitive services, but it's in fact to talk about how they can help someone with any kind of disability, and to try to be as inclusive as possible so that anyone can benefit from all of the services that computers and the world actually provides, but by doing them in a nice way that works for everyone. So the first thing you probably see on my screen, and this is deliberate, is that I'm actually speaking, and at some point in time something is showing up here in Cyrillic, so in Bulgarian. And hopefully this is the correct translation of what I'm speaking, but this is just one example of how cognitive services can work, and this one is available for everyone for free if you are using PowerPoint, as simple as PowerPoint. Now, the thing you probably notice is that the screen is a bit smaller, so on top we actually have to have these texts here, but on the left and on the right it became a bit smaller, but we can adjust this simply because other people are also streaming. The aspect ratio has been maintained, but you get the idea. Now let's move on to the next slides. And one of the things you probably see is that there's a lot of animation here, or at least a lot of color, and this is probably not good for a normal presentation. Now this slide and the next slide is a slide that I usually present when I do presentations, and as you can see, a lot of movement going on, and this might not be a good thing. So I'm demoing this. This is usually the slide that I present, but as something that's actually not good, in something that should be inclusive, something that should minimize the difficulty of people reading it. But still, all of the remaining slides that you see from this point on will actually be much simpler. Now, this is the title slides, and of course, the title of the session, and let me speak this out loud, is going to be Develop for Inclusion Using Cognitive Services, an Azure Story. And my name is André Melancia. My simple contact is just to go to andy.pt, and you will be able to access most of the information from there. So you can go to LinkedIn, you can go to Facebook, Twitter, etc. And that page, although it is a very small page, it is a WCAG compliant. So this is a standard that exists, created by the World Wide Web Consortium, that guarantees that pages are accessible for people with any kind of difficulty. And we'll see a few of them that exists. Although it doesn't look like a good page, it's still very inclusive, and that has been around for about 10 years at least. Now, before I continue, I did mention that PowerPoint was actually something that you could use to do this kind of thing on top. So let me just move this to the top here. So this is what you see. And if you go here to slideshow, and if you say always use subtitles, you will be able to put the subtitles there. I am not able to change the setting at this moment because it is actually running. But if you click on this, you will be able to decide if this shows on top, if this shows in the bottom, if this shows inside of the slides, but on top or in the bottom. So it can still be the full size slide, but still reserve a space somewhere inside the slide to put the contents of this. Also, you can change the language. Here, obviously, it's Bulgarian, but I could change it just to English. So if I'm speaking in English, this can be English as well. No, nothing wrong with that. But because the audience is from Bulgaria, I feel that this might be better as a demo to actually show this in Bulgarian. Most things should work. No guarantees that this will be perfect, but should work in most cases. Anyway, another thing that I wanted to show you is when you go here, let's say this is my picture, and if you right click on this, you can say edit alt text, and this is something that you can add on websites. This is something that you can add here in PowerPoint. And if you click on this edit alt text, you actually have a text that says a person smiling for the camera. Now this is true, and there was a button here that I could press. It's not visible now, but there was a button I could press that actually described the image. So for someone with disabilities case, let's say someone who was blind would still be able to understand what the text was. Now, obviously, I can change this text myself, and in many cases I did. So, for instance, I've announced this session just a few minutes ago on Twitter, on LinkedIn, and on Facebook, and I've actually created the alt text to guarantee that whatever you see on the screen at this moment was actually well described. So this is the name of the session, blah, blah, blah. You see the person, etc. So I'm trying to describe the image, but this could be anything different. So in this case, if I'm going for here, I will actually say generate a description for me. This can go wrong or this can go well, but in this case, this is actually my cat. She's called Lioness, and it says a cat with its mouth open, which is completely true. She's actually not here, but she usually comes around every time I talk about Azure. Anyway, let's go back to the things that we were talking about. So let's go back to this and let's continue. Now, the next part I want to show you is a video. So this video takes about 2 minutes. I really hope that you are able to hear the sound. If for some reason this is not happening, please let me know. But in any case, you do have subtitles in the bottom. This video was created by Microsoft, and we'll just see what happens in the video. 1 second. Okay.
Yeah, everything is fine.
I'm Saqib Sheikh. I lost my sight when I was 7, and shortly after that I went to a school for the blind. And that's where I was introduced to talking computers, and that really opened up a whole new world of opportunities. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives. And one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like-minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphones, but also on the Pivot Head smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response, and you think, is everyone listening really well, or are they half asleep? And you never know.
I see two faces, 40-year-old man with a beard looking surprised, 20-year-old woman looking happy.
The app can describe the general age and gender of the people around me and what their emotions are, which is incredible. One of the things that's most useful about the app is the ability to read out text.
Hello, good afternoon. Here's your menu.
Great, thank you. I can use the app on my phone to take a picture of the menu, and it's going to guide me on how to take that correct photo.
Move camera to the bottom right and away from the document.
And then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
Years ago, this was science fiction. I never thought it would be something that you could actually do, but artificial intelligence is improving at an ever faster rate, and I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before. And in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far-off dream and building it one step at a time. I think this is just the beginning.
Okay, so this was the video. And this was about a 2-minute video, and we have a big list of things that we can try to do with cognitive services. All that you've seen there is actually being done with cognitive services, but I will get to this just in a minute. First of all, I do have 1 or 2 slides to show you, and then we'll attack this problem. Anyway, to mention that there are other problems other than blindness. So there's problems like problems hearing and, mobility problems, problems with hands, with legs, etc. There's a lot of different types of problems, and technology in many cases can actually come up with solutions. Now, the first thing I want to mention is that there are two types of solutions for the problems. One of them is a technological solution, and in this case, let's say we can do things with cognitive services, etc. We can do things with robotics, with prosthetics, prosthetic arms, etc. There's a lot of things that technology allows us to do, but it's always very important to mention that there's also a human solution. Okay, and this is the part that I'm going to mention here in the session, that this is the part that's up to you. So you are the one that has to guarantee that the applications that you create will actually be as inclusive as possible. This is not difficult. Okay, for instance, if you develop a website, including things like alt text, making sure you don't use things like tables for designing, but instead use divs and other small tricks, and that you actually include things like the titles of links and things like that. This is something that's so simple to do, and after you get the hang of it, you will do this automatically. You don't really need to think, oh, I need to do this because there's a rule for WCAG that tells me to do this. No, you'll start to do this automatically. Okay, so those human solutions, which is for you to guarantee that what happens if someone else needs this. I need to guarantee this as well. But in any case, we will have a look at how this is actually possible. Think about another thing as well, which is some of these situations are permanent. So someone who's blind will probably be blind for the rest of their lives. Let's hope not. Let's hope technology will change this. But others, for instance, are temporary. Let's say that you've witnessed an explosion or went to a rock concert and suddenly you cannot hear from 1 year. For some reason. Maybe in a few days this will be better and you will be back to your normal hearing, or at least your partial hearing. So this can be something that's temporary. Okay, whatever is the case, there has to be a solution, a technological solution to fix most of these problems, and these are some of the examples I'm going to show you now. Okay, now these are some of the examples, not all. These are some of the examples of situations that can be limiting to someone. Let's say if you are blind, obviously you will have exactly the same problem as we've seen on the video. So technology can help you in some of those ways. I will demo some of those ways. If you are visually impaired but not necessarily blind, so if you have any issues, you cannot see small things, you will need, let's say, a bigger screen, you will need bigger fonts, etc., maybe black and white, things like colorblind, so you are not able to see reds or a different color, that can happen. Things like epilepsy, for instance, the slides that I've shown you with all of the movement, one of the first few slides that I've shown you with all of those drawings could actually trigger something with an epilepsy. Someone who had epilepsy can actually trigger a seizure. Hopefully not, but more complicated animations might actually happen there. Hearing, if you cannot hear anything or you have partial hearing, in that case there are solutions, speech to text, text to speech, etc., that can actually help you with this. If by any chance you have no voice, so you are not able to speak, and in that case you have text to speech, so you can actually write it down in your keyboard and hopefully this will generate the sound. We'll see that in a bit as well. Anyway, there's many mobility challenges. For some of these, I would recommend some multiple technologies, in which case some of these are not, let's say, Microsoft-related technologies. But in any case, many of these mobility challenges can actually be helped with things like IoT. So if you consider things like Azure IoT, etc., this can actually help in some ways, okay? I don't want to focus on that part specifically, but just to mention that most of the things that you see here can actually be deployed in IoT devices and can actually help someone literally where they are. So it doesn't have to be a computer. It can just be an edge device, and this can be a device in a person's house like a Raspberry Pi. This is difficult because of the transparency, but I think you get the idea. But in any case, this should be very easy for you to use, and most of the things that you see here will actually work exactly the same way, whether you are developing this for a website or for a mobile application, or if you are developing this for an IoT device using Azure IoT. Now, I will try to show you some of the demos, maybe not all, but I will show some of the demos as far as I can show. Some of these will actually cover more than one of these topics, but we'll see what happens. But the most important part is about being human yourself, and one of these is to try to walk in someone else's shoes. So for instance, if you don't understand what it's like to be blind, maybe a good example is to cover your eyes for 1 hour or two and try to do the usual tasks you usually do, or the tasks you have to do, let's say in your website, something like that, without actually having vision, and you'll see that this is very difficult. Same with without hearing, so just make sure you cover your ears and see what's actually going to happen. If you are not able to hear anything, you will miss something, and this is very obvious for you because you are used to getting this. Someone who doesn't have this, maybe they will not miss this much, but they will still need some help in sorting out some of these problems and having some technology to help them get better results, let's call it like that, in some of these situations. Now, I do have a few friends with some of these disabilities. One of them, which is a good friend of mine here from Portugal, is actually blind, has been blind for so long, but he's actually working in IT, so he's a system administrator. And you might think, well, if he's blind, how can he do this? Well, there is some technology like screen readers that allow you to read. You can write on the keyboard normally, so anyone who's blind can actually write on a keyboard. That's not really a problem. But if you are reading from the screen, you can actually have a braille screen reader that looks something like this, where you actually put your fingers on it and it will actually improve a bit better. Okay. Now, these are hardware solutions. There's many more, but we'll talk about the cognitive services specifically. But this is just one example of things that you can actually do in terms of technology that can help you. But we'll focus mostly on the cognitive services. Now, first of all, and I will provide a slide with all of the links towards the end. One thing to consider is if you go to Microsoft.com/accessibility, you'll actually have a lot of information here that you can read. I'm not going to focus on this. I want to focus on demos mostly. But one of the things that we talked about before when we saw the video was the application called Seeing AI. Now, you can go here and download from the Apple App Store. This is not available for Android as far as I can tell. Maybe it will be in the future, but at present time, this can actually do some of the things that we've seen before. So it can actually recognize a person, text, etc., detect products. All of these things you can actually see using this application, but obviously this is something that if you can deploy some of this things similar to this anyway in your own products, this will be amazing for everyone. Now, I won't go into a lot of details about the app itself, but we will try to do some of the demos that work with the app itself, okay? Now, one of the things I want to show you is if you go to Azure.com, obviously there is a free tier, and you can use most of the cognitive services for free. So one of the options is click here on the green link, try Azure for free, and from this point on, you'll just follow all of the bureaucracy and get an account for free for 1 month. But after that, you will still be able to use most of these cognitive services that I'm going to show you for free, because they have a free tier that up to X thousand usages per month, depends on each service, of course, you'll actually get them for free. Okay. Now let's have a look at how this actually works. Let's assume you get an Azure account for free, and you go to something called the portal.azure.com, which is where you start, and then from here you can actually go here to cognitive services. Okay, and then from here, you will actually be able to find some of the ones that I've actually had on the desktop already, but you will be able to find a lot of different cognitive services. Not all of these apply to the session that we're going to talk about today, but some of these, like speech service, computer vision, custom vision, etc., these will actually work. Okay, now I will show you how to demo things using different techniques, using REST APIs, using just a website for the demo, or actually program programming things using C# classes, but this could be from a different programming language. And I will show you this even with the command line using curl. You can use wget if you prefer, but show you how this is all possible for you to try out all of these services. So each of these will be slightly different, but you get the idea that all of these services can be used in all of these ways. You just choose the one that's best for you, okay? I cannot cover everything in the demo, so that's almost impossible. Now, I've created some computer vision, some face API, some speech already, so we will see how this works. If I go again to my dashboard, somewhere here on the right, I have some of these created already, and we will go into some of this just in a bit, okay? Now, let's go back to Azure. And if you go to azure.com and then just select products, and you go here to products, AI machine learning, which is the first one, and then cognitive services, you will be able to see a lot of this. For instance, there's also, in the same area, there's also machine learning, there's also bots, etc. We will focus on cognitive services specifically. Now, you need to go down this page, and then you have 4 areas here, 4 categories if you prefer, and we can actually start with vision. Okay. Now, before I actually continue this, let me just mention that even in Azure, you can actually personalize the dashboard. Now, my dashboard looks like this, but let's assume that I wanted to customize it. You can actually go here and have some high contrast and things like that. But remember, this is for you, okay? So this is not for anyone else to see. This is for you. So if you are okay with this, this is usually okay. This is already a bit high contrast in some cases, but you could do even more high contrast if you prefer. I actually personalize this with my own techniques other than the ones that are there. Okay, let's have a look at, first of all, computer vision. So remember from the video, we actually saw that you could actually take a photo and then recognize what's happening. Or you could actually take a photo and actually see what's written. There's a few ways to do this. And no, I do not want any bot at this moment, but that's okay. And first of all, let's go for computer vision. Now, this gives you an example, although you will not be able to actually try it using an uploaded photo, for instance, if you wanted to try with your own photos, but you are able to try a few of these. Now, the first one just says a few bits of information, which are actually very useful for anyone using cognitive services, not necessarily for inclusion purposes, but you can detect what kind of things are on the screen, so people, etc. In the previous session, we've seen that we tried to detect people. There was also a chair. If you noticed on the previous session, they actually detected a chair there. But you can detect a lot of different objects using computer vision. And in this case, if you go a bit down, you'll actually have a text which is the same that I've used for the PowerPoint. This is the text that gets generated automatically, and you can use this for free in PowerPoint. You don't need cognitive services, just use this in PowerPoint and in other Office products. Now, this one says, people waiting at the train station, and there's a confidence of 83%. Now, let's assume that this is okay. We can try the skateboard. So that was another skateboard in the video. And this one, if you go down for a bit, there's going to be a young man riding a skateboard. That's also fine, but I would like to try this myself. By the way, you do have other information, like if it's a black and white photo, if there's adult content, if there's gory content, let's say if it's scary for kids, for instance. There's a lot of different information here, but the focus, we will keep the focus on this one. So let me just go to cognitive services. So start on the dashboard. As I was saying, start on the dashboard. Okay, here we go. So let's go to, let me just click here, and computer vision. For some reason, this did not pin there. So let's go to this one. And for computer vision, all you have to do is to go here, and you have some keys and endpoints. After the session, I will change them, don't worry. So in terms of security, you actually get endpoints that look like this, and you have a location, which in my case, it's all going to be West Europe, and you have an endpoint link. Sometimes you use the location, which is okay. Sometimes you use the endpoint, but I have them copy-pasted here on my side, so I will use some of these, okay? If you're not happy with this, you can actually regenerate the key, and this is what I'm going to do after the session, so that people will not be able to use my my computer vision thing. Anyway, you can actually go here to overview, and somewhere down here you can say API console. Okay, now there's an API console that we can use, and here you can say describe the image, which is actually nice. There's more things here: analyze the image, describe the image. In our cases, let's just use the describe image, but you know that you can do all of that. You can do things like OCR, so to detect handwriting, etc. I will leave this for you for homework if you'd like, but in any case, let's go to this one. So let's copy my key from here. Let me be lazy. I have a copy here, but let me just copy from this one. Cognitive services. It is going to be West Europe. Okay. And then they will ask you for an image. Now, I don't have an image. This is a problem. So let me just go to the website here and let's copy the... Okay, this one doesn't work. Okay. Let's copy one of these images. Let's copy one of these images. Let's see if this is an actual image. No, this is not an image. This is also not an image. This is a video. So I had an image. So I actually had an image. So let me be lazy for a bit and actually copy one of the images that was there. Okay. And actually paste this to make sure that this is okay. So this was the image we were just seeing. I got it somewhere else in the page, but if I right click some CSS things, so this did not show correctly, but this one is okay. So let's use this here using, let's see, this one. So I can go here and change the address. So I can just say this one, and then we'll see if this works. So I'm just going to click send. This is just as simple as here. Response to 200, which is fine. This is what we expect. And then remember the photo. So let's go back to the photo. So I have a wall, I have a computer, I have a person, and here I have a person sitting at a desk with a laptop and a phone. This seems all right. Okay, wall, person, desk, etc. Confidence, 41%. So this is not good. Okay, there is mostly blank here, but because of this part here, probably there's going to be some limitations. This seems like a faked image, a pre-prepared image. This is not very natural, but we could try something else. So let's say maybe this one. This is not an image. So let's say maybe this one is an image. Copy image link. Okay, so this one, we can try this one maybe. So let's see if this works. Okay, and last one, we will try one more, which is this one. Okay, so let's get rid of this one. So let's get rid of this one, pastes, and then close the quotes, etc. So this is obviously something we need. And then the response should be something like, a man sitting at a table looking at his phone. And, well, yeah, kind of, yeah. He is looking at the phone, okay. You can clearly tell it's a phone, so this works really well. There is more, but we don't have time to talk about all of this in one go. Anyway, this was actually seeing things using cognitive services to describe image. You can analyze it and see more details. You can actually have OCR, as I mentioned. There is more image tags, etc. There's a lot that you can do here. But okay, custom vision is probably something you might not need necessarily with inclusion. This is just something that you can go and actually select the images that you want. Let's say in this case here, let's say you have cans of drinks and you select all of the cans, draw rectangles around them, and then the machine learning training will actually focus on those cans and try to detect when those cans appear, and that you can actually make some comments like Coke Classic, Fanta, Lemonade, etc. So you can actually focus on things. Now, in most cases, this is probably not going to be useful directly for inclusion, but you never know. Depends on the type of things that you do. It might actually work for you. So this is very customized machine learning and very specific vision APIs. You also have face APIs. Now, let me give you an example how this works. A lot of different things. One of them is to detect the face, explain the person, see the emotion, etc. We'll see that in a bit, but which is face detection. But there's also face verification. Let's say you are comparing two images, or you are trying to identify who this person is from a list of people. The example here is okay. So you are comparing this, and this one is 83%. But let me just go here to browse and actually go. Let me just go for a second here, and let's go to this one. And I usually try a lot of different things. I usually try Trump, which is a very good example for these kind of things. Now, Trump compared to this guy is very different, 9%. But if you try to compare Trump with another Trump, happy Trump in this case, you'll actually get 90%, which is, 80 something percent, 83%. Now, but if you try to compare this happy Trump with another Trump, which is not so happy, it's more like neutral, but it's still fake Trump, in that case, you have something like 50%, 55% in this case. Now, this is definitely not the same person. The person on the left is an actor from Saturday Night Live, so this is not the same thing. But if you still want to compare someone, let's say you want to compare Borat, which is a completely different person. Now you get 8% as well, which is different. And if you want to compare to prove that someone does not look like Trump or might not be related to Trump, someone said that this woman was related to Trump in some way, and we actually get 39%, which is much higher than you would expect for something negative. So there might be some resemblance, there might be some family bonds in this case. Okay. Now, this was comparing two faces, so this can be useful if you want to detect who the person is in front of you, etc. You can actually detect them and maybe speak them out loud or something like that. With face detection, there is no demo directly here, but I can do this in a slightly different way. So I can go to, first of all, let's say dashboards, and I have my face API setting. So you always need to create them using the plus sign. But in this case, you can actually say discover or get started or something like that. So you can just go here and actually find how to get started, pricing, etc., and then develop. And this is getting started. It's actually here. Let me just get rid of this one, just because we need some space, by the way. Anyway, this example is a slightly different way. So the other one was using the API client directly, etc. This one you can use C#. So you have some libraries that you can create. So all you have to do is to create your subscription key and endpoint. And from here, you have libraries like actual classes that create all of this. So you can use C for this. C, C++, in some cases, C#, JavaScript, Python, etc. Each of the cognitive services will have different languages. Let's try the REST API because I want to do this in a command line. Okay. Now, the first one to do is there is a curl here on the first one, but I want to do the second one. I prefer to try because the results for the first one are not very interesting. I want to try the second one. And to do this, I'm actually going to open up a notepad. Okay, 1 second. I'm actually just literally going to open up a notepad, and there's going to be some text that I need to add here. Okay, so we can actually start with this image. Okay, although the image does not really show that much of him here, so maybe we can actually start with the previous image. The previous image was actually okay. So let's actually be lazy and try the previous image if that's okay with everyone, because it's actually more face in front. This one will work okay as well, but let's try this one. So this one is a good image for us to try. We have to replace the image. So there's an image here. We will try this one as well, but then we'll try this one, which is a bit better. Now, I need the face subscription here. So I go to my face, keys and endpoints, and I'm actually going to copy the key here, put it in the to do face subscription here. So I'll replace this subscription key, and then I need the endpoint, which is going to be this part here. Okay, and then I'm just going to replace it, something like this. Give me a second, and hopefully this is okay. Now, the first image we have here is actually an image from Wikipedia somewhere, so we can try it. Okay, just to make sure no bugs. So it's a woman, not really happy, just maybe neutral if you prefer, but let's give this one a try. So we're going to copy. We're going to start a CMD, so a commands, okay, and we're going to get to run all of this. Hopefully the result is going to be good. So we have Face ID, so smile, etc., etc. And because I am very lazy about this, and I will actually do something which might be a bit better for me, which is let's format the thing using this website. This can be a different one. By the way, this is from a previous test. Let's copy paste this. So we have this face here, and then we'll see it properly. So let's paste this up. So Face ID something. This will memorize the Face ID for typically 24 hours, but this can change. Face rectangle. So which part of the actual image in pixels does it have the face? The pose, left, right, up, down, etc. The usual stuff. And then gender female, age 23. Let's review. Age 23. Yeah. Seems all right. Okay. And then emotion, mostly neutral, as I was mentioning. So for a human, it's okay to detect emotions as neutral. For a computer, maybe not that much. Blur level, not that much. So it is fairly okay. But there is still some blurring. Okay. Good exposure, kind of. And then makeup, true. Eye and lip makeup. So a bit, yeah, we can tell this is true. And there is more. So hair, brown. And they assume that brown is 100%, the other one, gray, is 53%. Although because the image is not necessarily in color, it's kind of black and white, it might not be perfect, okay? Now, anyway, let's just try one more time, but with the other image, okay? Just to see what we can get in this case. So we'll actually try 1 second. Let me just replace this, and hopefully this will be similar. Let's hope, anyway. And we'll copy this. We'll try this out, and hopefully we'll get some result. Oh, okay. Bad codes. Oh, I know why the bad code is. So let's ignore this one. It's because of the ampersand signs and things like that. They do not look good in this. So if that's okay, I will skip this example. But this is actually not very difficult. If I had the file somewhere else, this would actually be working correctly. So sorry for that, but this is first time I'm trying with that specific image just for the faces. Okay, having said that, let's try something else. Okay, so let's try some more. And the next thing I have here is something called Forms Recognizer. Now, I'm not going to demo this. I'm just going to explain what it does. And if you go here, let's say to azure.com/products, etc., you will be able to find products, and you have something which is your Forms Recognizer. Okay, and the Forms Recognizer actually works in a very easy way. So you can go here and you can detect, I'm not sure if there's an example, there is. So you can take a photo of a receipt or something like that, and that receipt will actually be generated. Let's say a receipt like this, and let's see this one. And that receipt will actually be processed. Now, there's some predefined models for things like receipts like this, and you actually get the results like this, which is really nice. And then for someone, in the example of the app, you can immediately detect, all of the things that are inside, etc. In this case, maybe this one will have more information like item quantity for each item, etc. You have a bit more details, so you can read them out loud in your application and actually show them. Okay. Now, Forms Recognizer is actually, and you can create your own forms for other usages as well. But if this is predefined things, already work really well for inclusion. So something that you can use. This one does not show up in the list of cognitive services. This is a separate service, apparently, but it's still, for me, it's still part of cognitive services. Now, there is, let's say you have some low vision now, because we talked about things like blindness, which was our example before, but let's talk about some visually impaired situations, so low vision, something like that. Okay. Now, one of the things you can use is something called immersive, wait a minute, products. Okay, Immersive Reader. Okay. If you go here, again, Immersive Reader should also be a cognitive service, but this is about things including things like Teams, etc., and you can actually try them out. So I have, it looks like this, but I really want to try it out. So let's say I try this out with something that looks like this. Universal Declaration of Human Rights, English, that's okay, try it out. And then you jump into a separate page, and this can be in your own application, for instance. And here you see things big, small, etc., but you can actually customize it. So you can customize the size. Let's keep it just a bit smaller, okay? You can increase the spacing or not, depends on what your need is visually. You can change the fonts, and these are fonts that are pre-selected because they are the best for reading depending on each person. So each person will have one of these three, which is best. In terms of themes, different colors make different ways for reading. So this can help if you have different colors, black on white, white on black, depends on the case in most cases. But there is more, you can choose more. Okay, you can also change, for instance, if you have some nouns, you can have them in a different color. This is good for inclusion, but it's also good if someone is learning to read, for instance. This can also be very good. If there is any kind of difficulty when you are starting to read and you detect that you have some issue with learning how to read, this can actually help you a lot. You can separate syllables as well, so separate them to see how you are supposed to read the phrases. Good for younger people, but you can also see things like labels to understand if this is a verb or a noun, etc. But then if you click on something like this, let's say article, they will tell you it's a newspaper article with visual explanation. So this helps a lot. Okay. Anyway, in terms of reading, you can actually have smaller reading. So if you want to read, you just see the parts that you want. Even the line focus, which just shows you one single line, and then you can move on if this is something that you need for reading. But there is much more options. You can even translate, etc. You can see all of this in Immersive Reader. This is built into things like Microsoft Teams, ready to use. Just use it, right click somewhere, and then Immersive Reader, you are ready to use this if you really have to. Okay. Anyway, let's see a few more things, and let's get rid of this one. I'm actually going to make some space because I have too many tabs open. Okay, now we'll talk about speech. Now we have speech to text, text to speech. And before you actually saw that I was doing a text to speech thing actually showing up here. It's still working, but it's not on the same screen as I'm running. So obviously we're not going to be able to see it. But let's say that I wanted to run this continuously. Okay, so I just picked up one of the examples that I had. Let's say start. I picked up one of the examples that came from Cognitive Services, and I just adapted it a bit so it was continuous. And at this moment, it's actually running. I've actually used the one for translation, a real-time translation, but I didn't really use it. Okay, I didn't really use the translation, just this part. There are still some bugs because it took me like 5 minutes to do this. But you can tell that this is actually creating the thing. Okay, so now it's a new line because I had some space, okay, but it can actually continue. And let's say you can actually put this somewhere else and actually visualize this on top of the different plates, like always on top, etc. In fact, this one is actually literally always on top. I've actually added the functionality of always on top, so this works really well. And this is something that's very easy to do. So you add the always on top option, topmost, in your Windows, so it's easy to do, but you can do this in any other environment. Okay, this is just a quick example of this, and this is in docs.microsoft.com/Azure/cognitive- or minus sign services, and then somewhere speech, and you'll find this. Okay. Now there is more. Okay, we have a few minutes, but we have some more. Now we have speech to text. Let me show you how this works. And let's say you are speaking like I'm speaking right now. This is the demo we had before. And if I want to say the language, let's say I can even use a different language like Portuguese. Olá a todos. Será que me conseguem compreender enquanto eu estou a falar português? Okay, so this is obviously Portuguese, okay? You can actually try multiple other languages and they will translate this in multiple languages. Now, not all languages are available, but the language list is actually growing, so you can do this and actually see the results. This is speech to text, very practical, even for IoT devices. If you want to talk to devices and say, turn on the lights, turn off the lights, very practical. Now, you also have text-to-speech, and this one is what you get in the app when the app actually has some text and says, I'm seeing someone on a skateboard. So you can actually convert this, and let me just try it out again. Let me just convert this, and I can just say, let's try it out. So I have some examples here. Let's say play.
Universal Declaration of Human Rights.
I'm not sure if you can hear it.
Article 25.
Okay, but you can actually try it out if you prefer. If someone actually prefers a different, local dialects, local way of speaking, you can try United Kingdom, you can try Ireland, you can try Australia if you prefer. In some cases, this might look quite different.
You can replace this text with any text you wish. You can either write in this...
Okay, so this sounds slightly different. You can adjust the speed. So if someone needs, in terms of problem, they prefer to have slower speed, etc. You can adjust this. You can adjust the pitch. Some people cannot hear low sounds or high sounds in terms of frequency, so you can adjust that as well. A lot of things that you can do with this. Okay. Now, the next one, which is speech translation, is actually the example I just shown you on Visual Studio. Okay, so just go down here, and somewhere here you can actually try it out. So at the bottom somewhere, documentation or sample code. It's one of this. Okay, try the sample code. This is just what I did, and you can start with English United States and translate, for instance, for Bulgarian, and just say, "Hello, everybody. I really hope that this is correct." Okay, not sure if this is correct. Zdravajte. Something. Okay, you get the idea. So I really hope that this is correct. Anyway, there is more. So for instance, you have speaker recognition. This can be useful in an app. And for instance, if multiple people are speaking and you want to understand which one is speaking, okay, let's say you don't have sound for some reason, you cannot hear anything, and you want to understand which of the people is actually speaking. So in this case, I don't have a demo for this, but you can actually get some sound information about each person. Let's say person A, B, C, D. Each of them will have like a signature that you can copy to the clouds. And then every time that person speaks, you can actually say, oh, it's person A, B, or C. So this is very easy to do. Don't worry, privacy is guaranteed. You get literally an ID for these people, not the actual name. The actual name is defined in your own application, but still you can do speaker recognition by detecting the person who's actually speaking. And that can help in the middle of a conversation to understand how things really work. Okay, there is more. So vision, we talked about vision and speech. In terms of language, for instance, if you try to create a bot that looks like this, you'll probably need things like language understanding services, and this is actually very easy for you to use. So let's say you say, please do something, like turn on the light, open the door, something like that. You can just say, this is the example here, turn on the right lights, which is the phrase, but then Louise actually generates something which is an intent, which is basically the action that you want to take. In this case, it's going to be turn on, and the entities are basically the parameters that you want to get. In this case, it's a light, and it's the one on the right because you defined that as a, let's call it a parameter. It's an entity, but let's call it a parameter if you prefer. If you say switch all lights to green, you can actually say that the color, which is another parameter or entity, is actually green. If you say floor light to green, you actually have two parameters, one for color green, one for floor light, like this. This is the basis of most of the bots that you can create. This is really, really nice. We don't have time to show bots, but at least you get the idea how this works. Now, you also have Q&A Maker. This is nice for you to do smaller bots with frequently asked questions where you have questions and answers. So that's easy. You also have Text Analytics, which basically is how you can detect, let's say you have a text and you can detect things like sentiment analysis, you can detect key phrases, the language that people are using, and you can even detect personal identifiable information, each named entity, what they are, date, time, range, locations, etc. You can detect all of this. In many cases, this can be useful for other things as well, maybe for inclusion. If you use this for inclusion, let me know how. Very interested to know if you are using any of the products that I'm not mentioning or that I'm mentioning very quickly for inclusion purposes. Let me know how you do this. Okay, this would be very nice to know. Anyway, final ones. Translator is the same as Bing Translator. Trust me, much better than Google. Trust me on this, this is true. You have a few others like content moderators. If you have like profanity images, etc., you can convert them. Personalizer might actually be good for you to have applications where the content actually changes to be more personalized to the likings that certain people prefer, and this can be used for inclusion as well. Anomaly detection is just for you to detect if there is a certain trend that happens on a regular basis and suddenly you deviate from that trend. In many cases you might use directly machine learning, but this is also available as a REST API or classes, so it's much easier to use like this. Okay. Having said that, I think that's pretty much covered most of the things that I wanted to talk about. And just to mention a few last slides, this will be available in the video on YouTube, etc. And let me just skip this part. So this is actually how cognitive services work in the end. Basically, you receive a request in your own servers. You send it via a REST API. Internally, it's going to be a REST API. Something happens, and you return the information back to your servers. This is not very detailed, but I really don't want to go into the details of this at this moment. Okay, anyway, I'm not sure if anyone has any questions, but given the time, we probably have some limitation here. So let me just give you a list of links. This will be available if you pause the video. You will be able to see some of the links that we talked about today. And finally, I really want to thank you and say one final thing about this slide here. So first of all, I usually show the thank yous in a single column. It's a good idea to increase the font so that people will be able to see this a bit better. And finally, this thank you here that you see with your hand is actually done in American Sign Language, but other languages are similar, but not all sign language is the same. So this might work with a few different languages, but not all. Okay, so I really want to thank Michael for having me here. This was fun to present this session. Please let me know if you try these technologies for this specific purpose. I would be happy to know about this and even to share this with the world that you are using this for this kind of usage. Okay, so thank you very much for having me, and well, get in touch. Thank you very much, everyone.
Thank you very much, Andre, for coming. And hope to see you soon again.
Okay, thank you very much, Michael. Great initiative. Thank you.
Thank you. Thank you. Thanks to everyone who joined this event, and you can review and watch again all these sessions because streaming is available in several platforms, in LinkedIn, in YouTube, and Facebook. And you can expect in January Global AI Bootcamp. So we will have bigger event, hopefully hybrid with in-person attendance and also online. Thank you one more time and hope to see you soon.